presentation. So I will talk about malware, obviously. And when we talk about threat actors or malware developers, they are using a lot of different techniques to conduct actions into the infected machine. But some techniques are related to evasion techniques, and they are highly regarded by attackers because evasion techniques are used to bypass security in place or avoiding detections and security solutions. So this is the main topic of my talk, where we will learn more about evasion techniques, what are the current trends, and what can we do about it. My name is Thomas Roccia. I'm currently working at Microsoft as a senior security researcher. So my work is mainly focused on threat intelligence, malware analysis, and also malware tracking. And I've been studying evasion techniques since 2015, something like that, 2014 maybe. And yeah, if you want to learn more about my work, you can visit my website, and you can also follow me on Twitter or Mastodon these days. Okay, before to continue on that presentation, just how many of you already dealt with malware? Raise your hand. It could be for blue team exercise or incident response, malware analysis, but also for penetration testing or red teaming. Like some of you which are working on red teaming are also developing malware. So raise your hand again. Okay, almost everyone. I was expecting that. So that's cool because this presentation is exactly for you. In this presentation, so we will discuss about several stuff. First of all, I would like to define what is exactly evasion techniques and why it's really important. We will also dissect some practical examples with famous malware that are currently using evasion techniques, and we will see how they are using them to bypass the security in place. And then I will conclude the presentation by introducing you a project that I'm maintaining since a while, which is an open source project, which is completely dedicated to evasion techniques. Okay, so let's talk about the definition of evasion techniques. So evasion techniques are interesting because this is not only used by malware, this is also used by legitimate software to protect the code and avoid cracking, or also avoiding the copy of the code and the reproducing of the application itself. So evasion techniques can be used by software also to avoid static analysis and also dynamic analysis, and also human analysis like reverse engineering, disassembling, anti-debugging, and so on. For malware author, this is also an interesting technique to use in malware to avoid and evade security solution, static analysis as well, and dynamic analysis, security configuration. In some cases, there is some security configuration that will detect a specific malware. And also avoiding human detection, meaning malware analysis process, running the samples, reversing it, and so on. So these techniques are very important for malware as well because they will use evasion techniques to stay the longer into the machine and conduct malicious action. Because if the malware is detected right before infecting the machine, there is no point for the attackers because the malware will not have the time to run and conduct some stuff. Okay, we know a little bit more about evasion techniques. So now I would like to discuss about why malware evasion techniques matters. So first of all, in most of the samples, most of the malware that you can analyze or find during an attack or during your research will use evasion techniques. In 2017, we conducted a study about some statistics about malware that are using evasion techniques. And we found out that 90% of samples that we study have at least one evasion techniques. So it could be obfuscation, anti-debugging, anti-sandboxing. There is plenty of different evasion techniques. I will talk more about that later. If you're familiar as well with the MITRE attack techniques, if you have a look to the defense evasion, it's actually one of the most, the longest actually tactics in the MITRE attack technique, in the MITRE attack matrix. And this is the case because actually many malware are using evasion techniques. And the fact is that even the MITRE matrix is not complete because there is so many evasion techniques that it's very difficult to document everything. And yeah, finally, it's very important for attackers because the longest the malware will be able to run into the machine, the longest it will be able to do some exfiltration, ransomware stuff as well, or any kind of malicious activities. And for Defender, this is really important because you need to be aware of it to be able to detect samples quickly, but also when you are doing your analysis to understand why some tools such as sandboxing will not detect the sample. This is also important because there is actually a business around evasion techniques. We discussed before about legitimate software using evasion techniques. And for example, we have Temida, which is a legitimate protector used to protect the code. This is also used by malware. And there is also some business around it, like in some underground marketplace, there is some tools that are selling to attackers just to protect their malicious code. In fact, I'm not sure if you remember about the gun crab ransomware. It was very famous around 2018, something like that. The gun crab ransomware had a partnership with Anti-Crypter, which was a group at that time that was dedicated to creating evasion techniques, stuff for attackers. And GunCrab and Anti-Crypter at that time did a partnership to protect the different ransomware that was running by GunCrab. Okay, let's talk a little bit more about evasion techniques itself. What can we find in the wild, and a bit of more practical stuff. So there is, when we talk about evasion techniques, we can actually split evasion techniques into three main categories. The first one will be anti-security technique, which will be basically all the techniques used to bypass security solution, such as antiviruses. It could be IPS as well, firewall, any kind of security solution that you are running. There is some specific techniques that will be on a malware to bypass this specific tooling. The second one is anti-sandboxing technique. So sandboxing are used for a quick dynamic analysis of a sample to get a report about its capabilities. And basically, there is also some techniques that will be able to detect the sandbox environment. So it could be detecting the virtual machine environment. It could be detecting some processes running as well, but there is plenty of techniques. And if malware are using anti-sandbox techniques, your report from the sandbox will not be very valuable because you will not get a full understanding about the capabilities of the sample. And the last one is anti-analysis techniques, which are basically, if you are doing some malware analysis, reverse engineering and so on, or even running the sample into a virtual machine just to understand what is its capabilities. This is the anti-analysis techniques are basically these techniques, meaning it could be obfuscation. So it will be a bit more difficult to analyze the sample. It could be packing techniques as well to protect the code itself. It could be some anti-disassembling technique. So when you run the sample into an anti-disassembler, you will not get anything because they will have multiple tricks and the code will not make sense. And could be also some anti-debugging techniques. Anti-debugging is very used as well if you're doing malware analysis, and it could have some trick to avoid the sample to run into a debugger. And it could also be, for example, environment aware, such as, for example, detecting the process running. If you are running Wireshark, the sample will be able to detect that Wireshark is running and simply not run into the machine or run differently. So it's mostly used to harden the analysis and avoid the understanding of the sample. So that's why also evasion techniques are very important if you are doing malware analysis, incident response, and mainly if you are working on malware. There is actually one sample, one malware family, which is using a lot of evasion techniques. And we will see that in a short. Also, evasion techniques are very important because you can find them in every step, in every stage of an attack. So most of the attacks today are using a delivery file, and then they will have some mechanisms until the final payload that will run into the machine. So if we take these typical attack sequences, the first one, if infection vectors could be a malicious document that you receive by email, malicious document that will run a macro, for example. The macro can be obfuscated. They can also have some tricks to detect the environment and not delivering the second stage if it detects the virtual machine or the analysis environment. Then we have also some evasion techniques in the malware delivery process, meaning you will get a sample, in that case, an executable, for example. The executable can come packed with some mechanisms such as obfuscation, anti-debugging, and so on. We also have some evasion techniques during the malware execution, like the malware will run, and it will try to, for example, detect some element into the machine before doing multiple stuff or unpacking itself into the memory. And finally, we also have some evasion techniques during the connection with the command and control server, for example, like for exfiltration, but it could also be communication with the C2 for retrieving the command, or also, for example, getting some information from the command and control. So that's why it's very important to understand evasion techniques and to understand at which point of an attack you can find evasion techniques, especially if you are doing some analysis and nothing is correct or nothing is making sense. All right. I wanted to talk about Emotet. Emotet is a infamous malware that used to be a bunker, and it moved over the past years to be a loader, meaning it will infect machines and reselling the infection access to different threat actors, such as ransomware group, for example. And Emotet is quite interesting when we talk about evasion techniques, because it uses a lot of different mechanisms that are very interesting. So I believe this is a good use case to present you here today, these samples, and to understand a little bit more how Emotet is actually using evasion techniques. This one is an example where the first infection vector was a malicious document with a message that forced the user to enable the macro to see the contents, regular stuff. The macro in that specific sample is obfuscated, so it's not super easy to analyze it at the first view. You need to spend some time on it. The malicious macro is actually running into the system a PowerShell encoded base 64 strings, and the strings decoded is actually a PowerShell script that will run some HTTP request to a C2 server, a domain name. And these specific requests are directly encoded into the PowerShell script. And there is some mechanism that will build the domain name. So even if you disobfuscate the PowerShell, it can take some time to understand exactly what the PowerShell is doing. And finally, so the request, the HTTP request to the remote domain. And to get the sample, it is exactly the samples needs to run a specific HTTP request to get the sample. So if you don't have the request, you can go to the domain, but you cannot download the samples because you don't have the specific HTTP request. So that's the kind of obfuscation we have with Emotet. So in that case, I retrieve the executable, and I wanted to learn more about it. So the first thing that you do when you get a malware before to reversing it and getting more information about it. It's just getting information about the structure of the PE, portable executable. In that case, there is, this one was interesting because it was bind with a legitimate software, meaning when you run, for example, strings into the sample, you will get a lot of different strings, and many of them were legitimate because it was associated with the legitimate file. And that's a common technique used by malware to, for example, bypass machine learning classification. So in that case, Emotet was using a legitimate software. And it also has some fake metadata in the structure of the file, which are not really an evasion mechanism, but it can trick some users or some analysts as well. Getting more knowledge about the structure of the samples, which is interesting, is to understand more about the capabilities of Emotet. So what I did, I ran Emotet into my disassembler, and I wanted to start my reverse engineering session to get more knowledge about it. And in that case, the samples were using what we called code spaghetti, meaning it was using a lot of different fake operations, obfuscating the control flow, which is a bit difficult to analyze when you have a look to this kind of flow graph. And especially, you can spend a lot of time trying to reverse everything, but it's just a waste of time. So you have to be able to know about it, to spot different mechanisms of fake operation that could be used, and just focus on what could be interesting. And at the end, when the samples were running, it also built some domain name into the stack. So it was dynamically decoding the domain name when running. So when you were doing your static analysis, you were not able to see anything because all the domain name was completely obfuscated. So in that case, it was more easy to run the samples and monitor the traffic to retrieve the domain name. And it's also interesting because the communication with the command and control server were encrypted. So you couldn't see the data that was exchanged with the samples easily. And that's also another obfuscation mechanism to avoid the detection, the analysis, and so on. So as you can see with Emotet, if you want to analyze it like very deeply, understand every piece of code, it can take a lot of time. And when you are dealing with an outbreak or an incident response, you most of the time you don't have time. All right, all that introduction about evasion techniques and what we can find in the wild. To introduce you the Unprotect project. The Unprotect project is an open source database that catalog evasion techniques. So I started this project in 2015. And at that time, I was working mainly on incident response, and I used to travel a lot for several customers. And when I went to the customer site, most of the time they said, we already have the antivirus in place, we already have some security solution, but they don't detect anything. So I started to get more knowledge about evasion techniques, just to explain them that malware are using this kind of techniques to avoid the detection. In some case, when you run your tools or when you have all your security in place, it's not enough because malware will use that techniques just to bypass your security in place. So the project started in 2015. At first, it was a wiki, a simple wiki where I started to document everything and to list the different techniques. I did the first presentation of this project in 2016 at the BotConf conference, which is a famous law enforcement conference in France. Then in 2017, I created some tooling around the project. Mainly, one of the tool I created was a proof of concept. My idea was to create some artifact related to virtual machine environment into the machine, into a regular machine. And that way, if a malware is aware about this specific artifact into the machine, it will simply not run because it will believe that it's a virtual machine environment. So that's the kind of proof of concept I've been working on. In 2019, I talked about the Unprotect project at Black Hat Asia. And one of my friends, Darkoder SC, which is French as well, joined the project. And we started to rebuild the website and the project itself in 2020. So we did a full redesign of the project, and we started to document a little bit more, added more features and so on. In 2021, we added the API, and in 2022, which is today, we started some new additions and new features. So I'm gonna show you that in a short demonstration. So the Unprotect project is available on unprotect.it. On the first page, you will get information about the latest statistic about the database. Like at this moment, we have 205 techniques available into the website. We have 120 code snippets, and we also have detection 115 detection rules. And currently, we have 17 contributors. You can also see the latest techniques that was added into the database. And you can also have a look for a specific technique by searching directly into the search engine. So when you click on it, you will have the results which are related to the stuff you search. If we take the first one, kill process, you will have some information here about the technique. You will also have some code snippet when it's available, because we are still currently working on the database, and not all the techniques are documented at the moment. But in some cases, you will have a small code snippet. You can also have multiple code in some techniques. It's not only C++, it could be also Python or Delphi or C#. It depends on the contributor. And we also have detection rules. So we have YARA rules. YARA is used mainly in malware analysis to detect specific techniques or for doing some threat hunting as well. We also have some Sigma rules, if you want to try Sigma as well for these specific techniques. And we also have Kappa. Kappa is a FireEye open source tool from FireEye, which is used to automatically detect the MITRE techniques in a sample. Some techniques are not completely documented like this one, but basically that's the kind of information we try to have in the database. You can also look for a specific technique by looking to the map, meaning the classification. And the different techniques are classified by this one: anti-debugging, anti-disassembling, anti-forensic, and so on. Process manipulating as well. Process manipulating are mainly all the process injection mechanism. Like if you click on one of them, you will get the list of the techniques that are referenced into the project. And you can see the ID. You can see if a specific techniques already have a code snippet or already have rules, detection rules, and so on. You can also look for the technique list like that and have like all the techniques and directly looking for something specific. All the snippet list as well, and all the detection rules. In the About page, you can learn a little bit more about the project itself, why we created it, why it's important. You can also see the main contributors of the project. And we have here all our contributors that are listed and that contribute periodically to the project. If you want to automate something, and if you are working on evasion techniques, there is also an API which is available. At the moment, we are working on a Python package. That way you can automate the request of the database. From the API, you can retrieve information about the specific techniques, but you can also retrieve the YARA rules, the Sigma rules, and the Kappa rules, which is very interesting. If you are working with Python, for example, you can directly automate the retrieving of the Yara rules and running them into your data set, for example. And I'm also glad to be here today to announce a new feature, which is not yet available, but it's you will have a glimpse, an overview quickly today. We are actually building an engine where you will be able to upload a sample into the database and get a full report about the evasion techniques related to that specific sample. So at the moment, it's very basic. It's only a portable executable parser, but basically you will get this kind of information, mainly the hashes related to the samples. You will have details about the dose header with the different field, the description as well, and many other information. You will have also some additional feature like the file header as well, if it's available in the samples you want to analyze. The sections, so you will get more details about the different sections in the samples you want to analyze, which is also quite interesting because in some cases, sections can be can be used for obfuscate some data, or can be used if the sample is packed. We will get more detail about the mechanism used by the samples in the section. You can also see all the different DLL and the function used by the samples. That way you can have an overview about the capabilities of the sample itself. And some other features that are here, as well as the strings, extraction of the strings, and so on. So we are still working on it, but basically the goal is to have really something specific dedicated to evasion techniques. Like, for example, if we take the strings, you will get, in that case, you only get all the strings of the samples, but we are working on a way to classify the most important strings and to recognize strings that could be related to evasion techniques or could be obfuscated as well. So, as I said, the project is open to the community, and there is actually some resources if you want to contribute. But basically, the goal of the project is to document as much as possible the evasion techniques. It's a kind of an extension of the MITRE matrix, and the goal is really to get the knowledge, to provide more knowledge about evasion techniques. And I think it's interesting. I've been discussing with some people, mainly that are working in malware analysis, but also some people that are working on red teaming. And this kind of database is very interesting for them because they can reuse some piece of code for their exercise. And that's why we also provide the detection rules when it's possible, just to be sure that people can also be aware of it and detect the different techniques that we document into the database. If you want to contribute to the project, you can have a look to the website itself. There is a small button, contribute. And yeah, if you have an idea, or if you see something that is not documented currently, or if you see something that you would like to update, you can contribute directly to the project. To conclude on that presentation, so here I wanted to give you an overview about malware evasion techniques, and mainly what kind of techniques we can find in the wild. So that's very interesting, I believe, to study malware evasion techniques, because you can understand a bit more about what kind of techniques malware will use to bypass your security in place. If you spend a lot of time trying to analyze a specific samples and you don't know why, for example, it's not running into your debugger, that could be an evasion techniques. I think this is also interesting to study these techniques because this is highly regarded by threat actors. And there is many of different techniques that are going out almost every month. And yeah, finally, the Unprotect project is basically a way to provide more documentation and more resources to the community about evasion techniques. So I hope you learned something today, or at least you find this talk interesting. Thank you very much for your attention. And if you have any question, let me know.